All right, everyone, good morning. It's past 8 a.m. Let's go ahead and get started. So this week, we're going to be doing basically chapter 2 of the textbook, mathematical background. Might be a little bit tricky, so try to pay close attention. Sometimes I'll give you a chance to write stuff down and practice on your own. And sometimes I'm going to go really fast. So just bear with this lecture this time. And then the main focus, remember, is I need to give you guys time for your assignment. So let's try to go at a good pace. If I'm going too fast, let me know. And then, of course, you can always just rewatch the lecture. So couple classroom items. So let's review the syllabus real quick. We have homework, which is 18% of the grade. Quizzes, 18%. You have your midterm, 7%. Lab, which is right here, 36% of the grade is right here. 11% of the grade is the lab project, and then 11% is your final, which is also a project. So pay attention to this, because number one, as you can see, attendance is not on here. So technically, you don't have to be here. But I want to help you guys. So if this is the last time I see you until like week 8, you're playing with fire. I know that you guys are smart. You know that the lectures are online. You know that the MATLAB is online. You know that everything is online. You know you can log on through Zoom. And that being said, all you have to do to just let me know is just email me. Just email me. Like you don't even have to tell me if you're sick or not. Just email me, and then I'll be marking that down. But seriously, if you can make it to class next week and the following weeks, I know it's early, but seriously, it's in your best interest, because look how big that chunk of your grade is. So again, y'all are smart, so there's no attendance technically required. But really, if this is the last time I see you until week 8, and then you're gonna email me or Dr. Barsanti, if you have an 89.7% of the class, I can tell you from personal experience, I took this class before. I can tell you, she probably won't round that grade. Okay, so if it's at the end, you're out of luck. But if I see you coming to class, you come to my office hours, you do the homework, you're on time. Most importantly, communication. This is super important, not just for class, but for real life. So in regards to leaving class early, again, if you want to leave right now, like, attendance isn't required, but just try to stay until the end, because we need to have this lecture hall, and we're kind of like the test subjects, right? This is the first time that they're opening this building, and Dr. Barsanti has this really awesome lecture with this really awesome view. So it really would just be great if everyone just keeps showing up every single week on time. You do your homework and you come to office hours. All right. Are there any questions about those items? Sounds good? All right, so like I said, we're gonna go really fast. So we're doing chapter 2, basically the mathematical background. So hopefully you guys have started the reading. You should be doing chapter 1, 2 in the appendix, as well as chapter 3. How was yesterday's lecture? Decent? Good? So far so good? All right, so basically chapter 2 has basically all the calculus that hopefully you've had most of this by now. Most of you guys had calculus. Most of you guys had multivariable vectors. Some of you guys have linear algebra. So, just think about the prerequisites. The prereq for Math 10A is Math 9A. The prereq for Math 10B is Math 10A. Again, we won't be doing too much multivariable. The main focus is matrices and linear algebra. So if we can get to Cramer's rule by today, then that would be ideal. So today's focus is on Cramer's rule. So let's try to go over quickly the first 3 sections, and then Cramer's rule is your assignment. This is going to be your first, let's say, like pre-numerical method as your assignment. The rest of these, we won't have homework on it this week, but it's in your best interest to review them by yourself, especially ODEs, because ODEs are super applied for MATLAB. So ordinary differential equations, that's going to be chapter 10. All right, so let's review the operations. Let's go back to the basics: addition, subtraction, multiplication, division. Subtraction, of course, undoes what addition does. Division, of course, undoes what multiplication does. So these are just operations that we have on, any mathematical object, whether it's a number, a scalar. But importantly, the focus is going to be vectors. So we have vector addition, A plus B goes to C. So notice how a vector, the way that the notation in your textbooks is going to be either boldface or with the little arrow on top. So if it's a little arrow, it's a vector. How do we add vectors together? So go ahead. Yes. Okay, so you can do it algebraically. You can add element by element. You break it down, or there's a visual representation, which is called something rule. You make a parallelogram, and then you add the vectors. Remember that in physics? Dot product. The dot product, again, notice these are vectors. This is vector multiplication. What is the definition of dot product? So A dot B, what is that going to give you? It's going to give you a scalar, good. So dot product is going to be equal to the magnitude of the first vector times the magnitude of the second vector times the cosine theta of that angle. So if you want to calculate the angle, you're going to have to calculate the sum of the inner. So this is called the inner products. So this is your homework due this Friday. So this equation means that you're adding up the components of the vectors. If you need more help with this, let me know. Otherwise, I'm going to move on. Cross product. So notice that dot product, the resultant is a scalar. Good. The cross product, is this a vector or scalar? Vector. Good. So what is the meaning of cross product? What does the cross product tell you? Yes. So the cross product is another vector. So notice we have vector A, vector B. The resultant is another vector C. And then you do the right-hand rule. Remember that? And then what is the magnitude of this? What is the magnitude of this vector? Yes, AB sine theta, good. It's also equal to the parallelogram spanning the space of the vectors when you cross them. So if you need review for that, let me know. Otherwise, I'm going to move on. We have calculus, differentiation, integration. So what's a derivative? Yeah, integrals. Area under the curve, good. All right, so the determinant, this is going to be a matrix operation. We'll talk about this one. We'll focus on the matrix ones. So we have determinant, the transpose of a vector. So what does transpose give you? You switch the columns and the rows. We did that last week. Remember when we added the single quotation? The inverse we'll probably talk about next week. But notice how, addition has an inverse, which is subtraction. Multiplication has its inverse, which is division. So you can think of the inverse matrix as a division operator for matrices. And then next week, we'll talk about how you will get the identity matrix. The last of these, not focused for this class, but you should review them yourselves as engineers. The del operator, is this a vector or scalar? Del is a vector. The gradient, okay, so gradient is an operation on, so is the gradient an operation on a scalar or a vector? Taking the gradient of a scalar function, okay, and then the gradient gives you a scalar or a vector. Scalar, good. Divergence, so now you have del. Divergence, you're dotting the del operator with the vector, and then you're getting a scalar or vector. You're getting a scalar. Scalars, remember, are scalars numbers or lists of numbers? Scalars are just numbers. And then lastly, curl, again, we have cross product. So notice, look, dot product corresponds to divergence. cross product corresponds to curl. Make sense? So if the cross product is a vector, then the result of the curl should be a vector. Good, good. So this is basically all the math review we're gonna do. If you have trouble with this, please come to my office hours. I'll gladly go over all of these. So this is basically, you know, your entire until college, right? And then this is your Math 10A, Math 10B, your Math 9A series, and then you have some linear algebra stuff, and then Math 10B stuff. So any questions before moving on? Yes. I'll post the video. Raise your hand if you really want the slides. You really want the slides too? Okay. All right. I'll try to post the videos and the slides. I'll do a Google. Yeah, I'll post all the PowerPoints. Thanks. Okay, so a function. I gave away the answer. So what is a function? Good, good. So one example of that could be a three-dimensional function. You might have the inputs as the x, y, and z components. X, y, z components of some scalar function. For example, temperature profile or heat profile, concentration might have different representations of functions. You have the mathematical operation, or you have the mathematical equation, and then the output should be a figure. Scalars, as we said, are elements of a field. Vectors, we can properly define vectors using linear algebra. So technically it's an element of a vector space. We have the unit vectors. So what is a unit vector? Yes, yes, the unit vector is a magnitude of length 1. So we have I hat, j hat, and k hat in the x, y, and z directions respectively. And then we have the value of the I hat. So I hat is 100, 101, and 001. Okay. And so now the main focus for the rest of it will be matrices. So it's useful to know how to define vectors and the magnitude of vectors. So just keep in mind, if you see the little arrow, that's a vector. If you see the hat, that's normalized with respect to the magnitude. And then that should be equivalent to the vector itself divided by the magnitude of the vector. Okay, so remember that just like a unit circle is a circle of radius 1, the unit vector is a vector of radius 1. We don't have time to watch YouTube videos. I have tons and tons of YouTube videos, recommendations for you guys, so just let me know. We can define vectors physically or visually as the arrow pointing from the origin to another point in space. So that could be velocity vector, acceleration vector, force vector. That's going to be the physics perspective. And then the computer science perspective is going to be defining vectors as arrays. And then hopefully mathematicians can reconcile those two definitions. Highly encourage you to check out some linear algebra courses and then try to define them properly for yourself. All right. So calculus again, we have functions. So again, an independent variable goes inside the function and then outputs a dependent variable that's a function of the independent variable. Differentiation, we have the derivative. So it's based on the definition of the limit. The limit goes to 0, and then we can define the slope at every point. Integration, which again gives you the area under the curve. And so the relationship between the derivative and the integral is given by the fundamental theorem. So there are two fundamental theorems. Everyone write this down if you don't have this memorized by now already. So the integral of the function is given by the difference in the magnitude of this new function, which is the antiderivative, right? So if you want to integrate a function, you need another function which is the derivative of that function. So integral of lowercase f of x dx is the difference of capital F delta f, where capital F would be the antiderivative of f of x over ab. And then similarly, the second fundamental theorem states that if f of x is continuous over an open interval containing the number a, And for every x in the interval, we have the derivative of the function, the derivative of the integral from a to x of f of some dummy variable. You can call it a c, you can call it u, whatever you want. And then that will output the function itself. Okay? So in other words, velocity is the derivative of what? Position. Or velocity can also be called the integral of. Very good. Okay. Any questions about the FTC? Another example, momentum versus force. So which one is the derivative of what?
Force is
Force is derivative of momentum. Very good. All right. Great. So now let's talk about the main aspect of this class, MATLAB. Remember, MATLAB stands for this side. MATLAB stands for good, Matrix Laboratory. So we're dealing with matrices. Matrices are arrays of arrays, just like we saw in Excel. Excel is a giant matrix. So last time we were sort of discussing how to multiply matrices. We can multiply them element by element, or we can multiply matrices following the actual mathematical operations, the actual rules. So let's start with matrix multiplication. So let's say you have this 3x3 matrix here, A, this 3x3 matrix B. Everyone copy this down. I'll give you a couple minutes to calculate C, which is equal to the multiplication of A times B. So try to multiply this matrix. So suppose I give you all 9 values of here, all 9 values of A and B should have 9 values of C. So your first hint is you take the first row, first matrix, multiply by first column of the second matrix, multiply those together. That would be the dot product, the inner product. Second step, keep the first row constant, shift over from the first column to the second column. Should be like that. Take the inner product of those. And then you repeat that process for all the elements of the matrix. The third element be first row is constant, third row, second matrix. Now we want to move on to the second row of the matrix. So now we're going to shift first column, the first matrix, the second row. And again, you repeat that process. You're doing some iterative steps. Okay. So in general, your equation would be this funky equation. So let's look at this equation first, real quick. So I'll give you guys a second to copy that down. So remember, the subscripts are not values, they're indices. So A11 is the first element of the first row. A12 is the second element of the first row. A22 is the second element of the second row. A32 is the second element of the third row. Okay, so we have rows, comma, columns. So the indices are arbitrary. We can call them IJK, we can call them LMN, we can call them XYZ. We have some Qs in there. Don't worry about the indices. The indices just tell you where you are in the matrix. So if you have C22, go to second column, second row. All right, so let's look at the summation symbol. The summation, you see summation, that's going to tell you you're most likely going to do an iterative procedure. In this class, we're going to do lots and lots of iterations. You do one step, you shift over, you do the second step, you keep doing that until you're done. Iteration, right? So I is going to be the arbitrary index for the first element, and then J is the second one, and K is the third one, right? So what is the condition of, this is the condition of matrix multiplication. So notice we have A sub M Q and B sub Q N, okay? So what is the condition? Yes, the Q's have to match. So what is Q? So the number of columns, so 3 columns in this matrix has to be the number of rows in this matrix, okay? So columns, this matrix, rows of this matrix. If you forget, just recall the inner dimensions. You see how we have the Q's are like touching? That's how you know. The Q's are touching. And so the summation can also be simplified. This is actually, I believe this is Einstein's notation. Einstein invented some fancy language in addition to all his brilliant theories. And then we can simplify this giant equation into just Cij. So if you have 2 indices in certain texts, that's going to be iterative procedures. So let's do an example. What you just learned, take what you just learned and then multiply these matrices. First, do it element by element. So that just means multiply the matrix element by element. And then multiply the matrix following the equation that we just discussed. Okay, so for element by element wise, we have two 3x3 matrices. So we have 3x3 matrix by 3x3 matrix. It's going to give you another 3x3 matrix. So notice that it's not always going to be the same. Sometimes you're going to have two square matrices. It's going to output a square matrix. Sometimes you're going to have a 2x3 and a 3x2. And so in this case, element by element wise means, right, you have 9 elements. So you multiply these elements by element. So that just simply means take the first element, the first matrix, first element of second matrix, then you multiply these together, you'll have 9 elements. Okay? So that's what you should have gotten. For element, this is element by element. Okay? So that's one type of matrix multiplication that you can do on MATLAB. And the other type of matrix multiplication, this is what we just discussed, following the equation. So we take the inner product of each row with each column. So let's see what that looks like. The first row, the second column. So the first element by the first element, okay, so that's just 1 times 5. Second element, 6 times 4. Third element, all right? So that entire procedure only gives you just the first element, C1, right? Then you shift over to the second row, do that again, calculate that, that gives you the second element. Keep doing that, then that will give you this answer. Any questions? Makes sense, right? So how would you check this in MATLAB? So we can just define the matrices and then just check it with MATLAB. So remember, this is what we were talking about last time. So element by element, remember that means you have the period next to the operation, right? The dot. Whereas in matrix multiplication, you're following the rules of linear algebra. So if you don't have the period, it's going to assume that you're multiplying the matrices. If you do have the period, it's going to assume that you're multiplying element by element. So let's do an example. Okay. So the first thing I want to do is define the matrices. So how do we define a matrix? We have the vector array of arrays. So I'm just going to simply define the first array, which is 1, 6, 7, 2, 5, 3, and 5, 4, 2. So if I don't suppress that, run the output, I should have a 3x3 matrix. I don't like the way that it output that. There we go. So make sure that's the same. One, 6, 7, 2, 5, 3, 5, 4, 2. Right? The second matrix. Five, 5, 2, 3, 4, 1, 5, 6, 7, 3. Run that. Check out that matrix. All right. And for good practice, let's have some comments. So matrix example. And then given 3 by 3 matrix A, given 3 by 3 matrix B. All right. So first, let's calculate A times B element by element. So we have A times B element by element. So let's just call it C element by element. Okay. So again, we have the dot to represent that we're doing it element by element. A dot times B. So that should be the first example. We just take each element, multiply it by the next element. Simple as that. Five times 1 is 5. 6 times 2 is 12. 7 times 3 is 21. Great. Okay. I'll suppress that one. And then multiply A times B. So that's just going to be the multiplication. So that's just A times B. Run that. And then now we have the inner product of the first row and the second, first row and first column, inner product of the first row and the second column, so on and so forth. So if you really want, you can just make any size matrix, multiply by any size matrix, put in some random numbers for practice, and you have essentially infinite number of practice problems. We can just change these numbers. These can be any numbers, whatever you want. This is just arbitrary at this point. So that's the cool thing about MATLAB, right? You just have your initial script, save that for your code, take note of what it does, and then you can use that code for the rest of your career, basically. All right, any questions about that so far? Okay, so again, the period, MATLAB, element by element, no period, matrix multiplication. All right. So next, let's talk about determinants. So now you have a 2 by 2 matrix. I'll give you 1 minute, calculate the determinant of this matrix. So again, you can define it properly. You should look into how it's defined, how this equation is derived. But as engineers, we like shortcuts. So we like the crisscross method. Crisscross, applesauce, top row, first element, last column, first element, last element, and then subtract second element, third element, right? So that's the determinant. Also, see how it's derived, see what this determinant tells you. Determinants are really fascinating because you're going to shift your vector space in 2 or 3 dimensions. So we're not going to be focusing on vector spaces too much, but it can be a lot of fun. Very visual, it can be very beautiful. So that's a 2 by 2 matrix. Let's do crisscross applesauce. So now that you know 2 by 2 matrix, of course, now we can do 3 by 3. So the way you do 3 by 3 matrix is you're going to sort of try to visualize where these 2 by 2 matrices lie within this 3 by 3 matrix. Okay, so you already wrote down this matrix before because it's the general one that you wrote on the top of your page, right? So the first one, the determinant is going to be a set of 3 elements. So first you look at the first element, A11, and then notice we have this 2 by 2 matrix here. So A11 is your coefficient. A11 is your coefficient, and then you do crisscross applesauce for those 2. Okay. The second one is a little bit tricky. the way you can visualize that is you ignore the one under the second element. And so everyone pay attention to this. Some people like to subtract this and then take that matrix, right? What I like to do is I like to just add it. So keep this positive. And then you imagine that you're shifting this one to this side. If you like adding it like this, that's easier for you. That's great. If you like to memorize it, you have to shift this. So in other words, just take the inverse of this, or just subtract this value. Make this positive, make this negative. Should be the same, right? You're just factoring out the math. The second one is a little bit tricky. The third one is just like the first one. So you take the third element, A13, that's your coefficient, and then crisscross applesauce. All right. So raise your hand if you've seen this before. Oh, good. Okay. So what is one of the applications of determinant? How can you use this regarding vector multiplication? Yes, exactly. The area of a parallelogram, which is also given by, for two vectors, cross product. Bingo. So in other words, for the cross product, your A12, A11, A13, that's going to be your I hat, J hat, K hat. So that's why when you multiply these, there's going to be your I hat, J hat, K hat. Multiply them out. That's why the cross product is a vector. Otherwise, if you have all scalars or just general matrix, you're just going to get the determinant of the matrix. It's going to be a single value. So far, so good. Okay, the last part, we're going to ramp things up. Let's combine everything we talked about. We're going to talk about Cramer's rule. So Cramer's rule, now this is, everything else was just preliminary. Hopefully everything else was at least somewhat familiar. Cramer's rule is a solution of a system of simultaneous linear equations. Cramer's rule is a solution of a system of simultaneous linear equations. So let's say you have the system of equations, three unknowns, three equations, three unknowns. So can we solve this equation? Can we solve this system? Yes. How do we know? Three equations, three unknowns. Do they match? Yes. So degrees of freedom cancel out, you get 0. Three equations, three unknowns. If I had three equations, four unknowns, can you solve it? No. If you have n number more unknowns than equations, you have an infinite set of solutions. That solution would be another function. Okay, so Cramer's rule is an iterative procedure. It's not quite a numerical method, but it is a numerical procedure. So the first step is, do we see how, let's kind of reorganize this a little bit. We have some x's, we have some y's, there's some coefficients. Let's try to line them up. So let's rewrite this a little bit. How do we write this in matrix form? Let's line up the x's, line up the y's, line up the z's, line up the coefficients. Okay. We have, this is your template. This is your equation. You have a 3x3 matrix, 2 column matrices, 3x1. Okay, we're gonna go fast. Try to keep up, but if you don't, we can go over it again. And then this is gonna be your assignment. So I'm giving you the template so you guys can work on your assignment. All right. So the x's are lined up, the y's are lined up, the z's are lined up. So what's gonna go here? What's this 3x3 matrix? Coefficients. The 3x3 matrix is your coefficients. So what goes here? The first element, 2, Bingo. Perfect. The second one, let's do the third one. What goes here? 5. Perfect. This one is the tricky one. This one is the tricky one. So this is your variables. So what goes here for your unknowns? Perfect. Perfect. So what I want you to do, build that matrix and then multiply this. You have a 3 by 3 matrix and 3 by 1 matrix, right? You can multiply this. 2 ways of writing the same thing. We have the algebraic way. We have the linear algebra way, right? X, Y, Z. This is your matrix of coefficients. These are your unknown variables. These are your outputs. That's what it should be equal to. Technically, if we really wanted to, we can subtract both sides, put 5 on this side, have a 3 by 4 matrix, and then set it equal to 0. Should be the same thing, but you're adding one more step. In future methods, that might be easier. You want to set it equal to 0. So keep that in mind. So the matrix of coefficients, unknown variables, and then the output. All right. So in general, we have A, X, B. So what is the size of A? 3 by 3. X, rows, comma, columns. So how many rows? 1, 2, 3 rows, right? 1 column. B, what is B? So B is the same size as X. Make sure you get that. All right. So B is the same size as X. So for your assignment today, unfortunately, you have to get that right. Otherwise, MATLAB won't give you credit. So Kramer's rule states that if it exists, the solution to the system is given by this equation. Kramer's rule states that if it exists, the solution to the system is given by X sub j is the determinant of A prime of j divided by the determinant of A. Okay. So what is the determinant? Let's look at the denominator first. What is the determinant of A? What is A? A is your matrix of coefficients, 3 by 3 matrix. So do we know how to get the denominator? Give me a thumbs up if we know how to get the denominator. The denominator, you take this matrix, you calculate the determinant. How do you do the determinant? You turn it into 3 2 by 2 matrices, crisscross applesauce. All right? The numerator is a little bit tricky. So the tricky thing for me is the notation. So what is X sub j? What is A sub j prime? What is that? So X can be written as X1, X2, and X3. X1 is just X. X2 is, so this is X1. X2 is Y. X3 is Z. All right? A sub j prime is the matrix formed by replacing the jth column of the matrix A with the column vector B containing the right-hand sides of the original system. What does that mean? First, we calculate the determinant of the coefficients. Calculate the determinant, have the coefficient of this guy, crisscross applesauce, coefficient of this guy, crisscross, coefficient of this, crisscross, right? So you do that, you get 20. That's the determinant of A. That's the matrix of coefficients. Now, we apply the equation to find Z. So we have A sub j prime, the determinant of A. So look, we have the denominator. So now we have this guy. So what we have to do is replace the jth column of matrix A with the column vector B. So we rewrite the entire matrix A. And look, this is A prime X. So we're about to solve for X here. So what are we solving for? X. So this is the same matrix, except we plug this guy into this column. See that? So plug that into the first column. And then the next 2 columns are the same. So for solving for X, what is J equal to? J equals 1, good. J equals 2, we're solving for y. So a sub y prime. So now we have the first column of the matrix of coefficients. We change the second column to the matrix of the values, right-hand sides of the system. We keep the third column constant. So in this time, we're solving for y. Good. Last step, we have a sub z prime. So what is j? J equals 3. So x, j equals 1, y, j equals 2, z, j equals 3. Now we keep the first two columns constant. We plug this guy into this guy. Make sense? So now when you read the sentence, does it make a little bit more sense? You're replacing the column, j equals 1, 2, 3. So do you notice that trend? Maybe when you take, multivariable, or you're going to take fluid mechanics, right? So when you're doing your three-dimensional equations, you have lots of 3D stuff. You have I, J, K, X, Y, Z, 1, 2, 3, L, M, N. You're doing lots of 3 stuff. Make sense? So first you're solving for X, then you're solving for Y, then you're solving for Z. Yes. Typo? Yep, that's a typo. Typo. Thank you. This is a typo. Was that your question too? Thank you. I'll fix that. So this is a typo. Fix that here. Plug that one into here. Now you have this equation. So now you have your equation. So what do we have to do? Now you have 3 matrices. So in total, you're calculating 4 determinants. You have your original determinant, you have your x determinant, y determinant, and your z determinant. All right? And that should be the answer. So the common denominator is 20, because we calculated the determinant of the first matrix. And that's it. That should be your answer. So you can either do this one right now, or that's pretty much it for the lecture. So remember, step 1, write the system in matrix form. Step 2, calculate the determinant of the matrix of coefficients, which is your A matrix. And then finally apply the equation to solve for X, Y, and Z. So that's kind of nice, right? We have this ugly system. You can solve it by hand. If you solve it by hand, or if you use, a solver, like, I'm not gonna check that you change your code or something, but you should probably learn Kramer's rule, because next week we're doing numerical methods, and this is just week 2. And a lot of the methods are really similar to this. We have some step where we do some preliminary work around, write it in matrix form, and then we follow some procedure, and then we do that procedure, solve for the unknowns. That's basically how this class goes. We're gonna have some equation we want to solve. Maybe it's from physics, maybe it's from chemical engineering, maybe it's water quality, and then it's kind of difficult to solve by hand. So now we have to tell MATLAB how to do that. All right. So for today, we can just do it by hand. Just calculate it by hand. So either do it on paper, or you can either do the calculations on MATLAB. But do not use matrix. MATLAB does have some automatic determinant calculations. So I don't want to see any determinant calculations. I want you guys to calculate by hand. These are your problems for your assignments. Go ahead and get started. They are due at the end of class today. That's normally when they will be due. But you only have 2 hours. So if you don't finish by today, I will give you until midnight tonight, until 11:45, out of fairness for Friday's class, because the solution closes Friday at 11:45. So if you don't finish by today, email me, and then we can work something out. First one should be pretty straightforward. Kind of like last time, you define your scalars and vectors. I'm trying to give you guys easy points, all right? So remember, I'm giving you guys easy points. So hopefully you can finish by today. If you don't finish, don't stress, just let me know. Communication is key. So remember, this is the first time we're doing this in lab format. This is the first time we're back since COVID. So if you don't finish, communication is key. MATLAB is tricky, it takes a lot of time. If you do finish early, remember, I have some tips for you. If you finish early, what can you do if you finish early? You finish the lab assignment, finish your homework. You can do the plus minus of your chapter problems. And then basically, if you ask me to leave early, if you lock at the door, I'm not gonna stop you. No, come back, please. I'm not gonna do that. But it's just in your best interest. If you want problems, I got lots of problems for you to do. There's hundreds of problems in the book. I can give you my grad books. You can check out the graduate text. You can do your other homework for other classes. Let's just try to stay until at least like 10, 20, okay? Does that sound fair? All right, go ahead and get started. I'm going to stop recording, but I'll stay on Zoom.